Hello everyone, welcome you all. I am P.S. Bondre from m.sc Part 2, Department of Chemistry at GBU. Today, I am going to talk about steroid hormones. Let's start. These are my contents. Introduction, skeleton, nomenclature, dice hydrocarbon, synthesis, net set question and references. Let's see the introduction. A steroid is a biologically active organic compound with four rings arranged in a specific molecular configuration. Steroids are lipid because they are hydrophobic and insoluble in water, but they do not resemble lipid. Cholesterol is the most common steroid and is the precursor to vitamin D, testosterone, estrogen, progesterone, aldosterone, cortisol, and bile salts. Let's see the steroid skeleton. This is a cyclopentanoperhydrophenanthrin. The four interconnected rings of carbon atoms form the skeleton of all steroids. The structure is also named as guanine. Guanine is a tetracyclic hydrocarbon with no double bonds. It is formally the parent compound of the steroid and its carbon skeleton is called the steroid nucleus. The steroid core structure is typically composed of 17 carbon atoms bonded in 4 fused rings. The three rings A, B, C are 6-member cyclohexane ring and D ring is 5-member cyclopentane ring. The steroids share a common 4-member cyclopentaphenanthrin ring, which are classified chemically into 5 major classes based on their total carbon number. Let's see what are the number of carbon and what is the name of ring system. As we know, basic ring system having 17 carbon. If there are 27 carbon, it can be called as cholesterol. 24 carbon, cholic acid. 21 carbon, pregnein. 19 carbon, androgen. 18 carbon, estrone. You have to fit this in your mind so that you can name the steroid easily. Let's see the nomenclature rule. If the substituent is attached to above the plane of the nucleus, it is shown by a solid thick line and represented by a beta. If the substituent is attached to below the plane of the nucleus, then it is shown by a dotted line and represented by alpha. If the configuration of substituent is unknown, then it is shown by wavy line. If some carbon atoms are missing in steroid nucleus, then the numbering of the remainder will not change. Let's see the example given here. Here the hydroxy group is attached to above the plane and represented by a solid thick line. Therefore, the nomenclature is andros 4 17 beta hydroxy 3-one. Let's see the other nomenclature rule. If side chain doesn't contain methylene group, this is indicated by the prefix nor preceded by the number of carbon atom that has disappeared. Example is given here. In this, the 23 number of carbon atom has disappeared. Therefore, nomenclature is 23 nor 5 alpha or beta colon. Next rule. If the ring contraction occurs in the steroid nucleus, this is again indicated by the prefix nor preceded by a capital letter indicating ring affected. As we have seen here, A, B, C ring are cyclohexane ring, and in this example, there is a contraction in A ring. Therefore, nomenclature is A nor 5 alpha or beta androsten. Next rule. If there is enlargement of ring in the steroid nucleus indicating by the prefix homo preceded by a capital letter indicating ring affected. Let's see the example. In this example, there is enlargement of B ring occurred. Therefore, nomenclature is B homo 5 alpha or beta pregnein. Next rule. If there is a ring fission or breaking occurs indicated by the prefix seco preceded by a number of position of bond broken. Example is given here. There is a ring fission occur between the 2 and 3 number of carbon atom. Therefore, nomenclature is 2,3 seco 5 alpha or beta androsten 2,3 bryoic acid. Now, dice hydrocarbon. Dice hydrocarbon is a phenanthrin derivative obtained by the dehydrogenation of various steroids. Any compound which gives dice hydrocarbon with selenium distillation is defined as steroid. Example is given here. As we know, all steroids derived from the cholesterol. Here, the cholesterol on selenium distillation gives dice hydrocarbon. Let's see the common steroid hormones, testosterone and progesterone. The molecular formula of testosterone is C19H28O2 and progesterone is C21H30O2. As we know, in androsten there are 19 carbon atoms are present and in pregnein 21 carbon atoms are present. Therefore, testosterone is derived from the androsten and progesterone is derived from the pregnein. Testosterone is the primary sex hormone and anabolic steroid in males and is a steroid from the androsten class containing a ketone and hydroxyl group at position 3 and 17 respectively. Testosterone promotes protein synthesis, while progesterone is an endogenous steroid. Ketone group is present in progesterone and it plays a very important role in maintaining the early stages of pregnancy and also plays an important role in brain function as neurosteroid. Let's see synthesis of steroids. Testosterone and progesterone are biosynthesized in several steps from cholesterol. Now see how testosterone is synthesized. First step in biosynthesis of testosterone involves the oxidative cleavage of side chain of cholesterol by cholesterol side chain cleavage enzyme to give pregnenolone. In next step, the two additional carbon atoms are removed by 17-alpha hydroxylase enzyme to yield a variety of C19 steroid. After that, the 3-beta hydroxyl group is oxidized by 3-beta hydroxysteroid dehydrogenase to produce androstenedione ion. And finally, the C17 keto group of androstenedione ion is reduced by 17-beta hydroxysteroid hydrogenase to yield testosterone. Now see how progesterone is synthesized. Progesterone, like all other steroid hormones, is synthesized from pregnenolone, which itself is derived from the cholesterol. In the first step, the cholesterol is oxidized with the loss of side chain starting at position C22 to produce pregnenolone. This reaction is catalyzed by cytochrome P450 Then, the conversion of pregnenolone to progesterone takes place in second step. First, the 3-beta hydroxyl group is oxidized to a keto group, and second, the double bond is moved. Now, let's set questions. First question. Which of the following is a steroid hormone? Option A, adrenaline, B, thyroxine, C, cholic acid, D, riboflavin. Option C, cholic acid is correct. Question number 2. Steroid hormones are dash and peptide hormones are. Option A, hydrophilic, hydrophobic, B, hydrophobic, hydrophilic, C, hydrophobic, hydrophobic, and D, hydrophilic and hydrophilic. Option B, steroid hormones are hydrophobic and peptide hormones are hydrophilic. Option B is correct. Question number 3. Which of the following groups are present in testosterone hormone? Option A, alcoholic. Option B, ketonic. Option C, aldehydic. Option D, carboxylic. Option A and B are correct. Question number 4. In steroidal nucleus, the groups denoted by alpha are option A, below the plane of the nucleus and shown by dotted line. Option B, below the plane of the nucleus and shown by solid thick line. Option C, above the plane of the nucleus and shown by dotted line. Option D, above the plane of the nucleus and shown by solid thick line. Option A, below the plane of the nucleus and shown by dotted line is correct. Next question. Testosterone is derived from option A, pregnenolone, B, estrone, C, androsten, and D, all of the above. Option C, androsten is correct. Last question. C18 steroid is option A, androsten, B, estrone, C, pregnenolone, D, all of the above. Option B, estrone is correct. These are my references. Steroid Chemistry at a Glance by Daniel Lednasser and Wikipedia. Thank you.